Okay, so I'm back talking to you about geometry. We're going through some of the sample problems in your homework, and up to a problem where you have a square inscribed with a circle inside of it, and it asks you to find the area of just the shaded region, these little corner regions. There's not a formula per se about how to find the area of corners. You won't find that necessarily, but we have a compilation of formulas that can help us find just that part. Like if we find the area of this entire figure, this square, we could then subtract the circle, and that would leave the area of just those four corners. So that's the strategy. A lot of times you'll have to use multiple formulas and subtract some things or add some things to find the area of shaded areas. So that's what we're going to do here. We're going to find the area of this is a square. We've got a circle that's 19 foot in radius for my example. So that means the whole distance through, the diameter through it would be 38 foot, right? So we just double that. It's 19 foot, and it's a square, so it's going to be 38 all the way around for the square. So the area of the square part, area of a square, it's really just the same as any quadrilateral. It's the base times the height, or the length times the width. Or, well, in this case, because they're the same amount, we could say side squared is the official formula. But it's just the length times the width, or the base times the height, all would come out in this case to be 38 times 38, and they're both in feet, so it would be square foot for that. So the area of the entire figure of the square would be 1,444 square foot. So that's the area of the square. Then we're going to subtract out the circle. So we need the area of the circle. The area of a circle, as we learned on the last one, is pi r squared. So pi, use your pi button to get the more exact answer, not just 3.14, but the full amount of pi. And then the radius is 19 feet here, 19 squared. So typing that on our calculator, you should get 1134.11. And that's also in square feet. It's an area amount. So again, the area of just the shaded parts, the little corners, would be the whole thing, 1444, subtracting out the circle. So we subtract those two, and then a final answer, the little corner parts, would be approximately, depending on what you round to there, and here I guess we had to round on that, but it'd be 309.89 square feet. Square feet are the area questions. Okay, number 17, we're going to go into talking about something we kind of saw on a previous video when we were doing the metric system, is how to convert out of square units using a conversion factor. Here's the question I have for you, a sample question. If you know 1 square yard is equivalent to 9 square feet. We used that previously, like I said, the metric system. Convert 54 square feet to square yards. So what we learned in a previous section is if we can say what we're converting, 54 square feet, put that over 1, kind of write it as a fraction, and then times it by a true statement, a unit fraction, something we know is true, so that square feet is diagonal. It'll help us to know whether multiply or divide this to get the right answer. And maybe you just kind of know that intuitively, but this is a methodical way that helps you always know for sure what to do here. So square feet, again, the question we're asked, put over 1, then times by, this is a true equivalent statement, so we can make this into a fraction. We want the square feet on the bottom, so 9 square feet, we want that to be diagonal, square feet, and 1 square yard are equivalent values, so they're like timesing by a form of 1. This divided by this would be 1. So it's like we're multiplied by 1, so we don't compromise the value. It's legal to do it this way. Well, then it lets us know square feet cancels diagonally. Also, you could cancel 9 into 54, so that's going to wind up dividing. Then you've got 6 times 1 in square yards, and it converts it to what you were hoping for, square yards. Another example like that, we'll move to, let's see, that was 17, number 18. On number 18, it says use that same information and convert 15.6 square yards to square feet. So kind of going the other way. So we take what we're asked, 15.6 square yards, place that over 1, then multiply it by a statement of truth where yards squared is diagonal, so we want the square yards down here, And we know that 1 square yard is 9 square feet is a true statement. They're equivalent. That way the square yards are diagonal and cancel, and that tells you you need to multiply this times this, and it'll come out to be in the right unit square feet. So 15.6 times 9, you can do that calculation, it's 140.4, and now it's in square feet. Number 19, another example using the unit fraction method again, just kind of comes back here. And my question on number 19 looks like this. It says 1 square meter equals 10,000 square centimeters. And we learned how to do that actually without them even telling us this. We learned about converting, but it's kind of nice. They wrote it out for us. Then it says use this information to convert 3 square meters into square centimeters. So I'm going to use the unit fraction method, although there's other ways to do it. But I'm going to use the method I described earlier. Take what you're trying to do, put it over 1, and then multiply it by a true statement so that meters squared is diagonal, so it'll cancel. So 1 square meter, it says, is 10,000 square centimeters. So I'll put that up here. These are equivalent. I can flip it either way, but I just want it so square meters is gone, and then it comes out in what I'm trying to go to. And that helps me to know to multiply. When I multiply this fraction across, 3 times 10,000 gives me the 30,000 answer, and it's in square centimeters as requested, so 30,000. All right, number 20 in my example, we have this house, a 3 or 4 story house or apartment complex. It says, and we place a 40-foot ladder against it, so we lean a ladder up here, and it's a 40-foot ladder. You visualize that ladder. And it is 24 feet from the base of the house or apartment. So it gives us that in the drawing. And then it says figure out how far up the ladder hits the building. So figure that value up. Now we're assuming that we're straight down, that this building is square and it meets at a 90-degree angle. So we're back to Pythagorean theorem here. So to figure out this distance, it would be a squared plus b squared equals c squared. We don't know this height. I'm going to call that a. We know that the length here, that would be b, is 24. And then the length of the ladder, because it's the diagonal distance across from the right angle, that is c, 40 squared. So again, back to that. A squared plus 24 squared is 576. 40 squared is 1600. Then equation solve, throw that across the line. 1600 minus 576 is 1024. And then we square root to solve. So square root is the last step on these Pythagorean theorem questions. The square root of 1024 is 32. And this is in feet. So we expect the ladder hits the wall at 32 feet up. All right, then lastly, I don't know how yours will be phrased on your particular one, but mine has a question about the classic 1939 movie, The Wizard of Oz. And if you haven't heard this before, you might go on YouTube and see the phrase that the Scarecrow says about the Isosceles Triangle. He kind of gets it confused with the Pythagorean Theorem. So he kind of confuses, there's Isosceles triangles, which aren't necessarily 90 degrees triangles. They're different, could be different. But an isosceles triangle just means that 2 of the sides are the same. You got 2 sides that are the same. That's isosceles. Isosceles. So the Scarecrow talks about an isosceles triangle, and then he confuses it with the Pythagorean theorem. So he says it wrong. He gets it a little bit wrong. He sounds really smart because he's coming up, with the wizard has given him his brain and all that. So he comes out with, he's supposed to be saying something really smart, but he actually misses it. So I hate to tell you that, but if you don't know that. But watch that again. And the last question just says, straighten out what should the Scarecrow have said. What he said in the movie is the sum of the square roots of any 2 sides of an isosceles triangle is equal to the square root of the remaining side. So that sounds really nice, but it's not actually exactly true. So it says correct that statement. And my example gives this as the way to say it. The sum of the squares of the two shorter sides of any right triangle is equal to the square of the longest side. That's what the Pythagorean theorem says. So anyway, have fun with that one, kind of thinking about how that you've got that now figured out. So as always, if you have questions, always let me know. Best wishes.